Welcome back, everybody. We're going to do activity 2 shortly. Somebody's connected with a video that doesn't show up on the recordings, I found out. So here's activity 2. I hope we're not sharing what I thought. Not that I know. So I want to go here. There we go. I hope everybody's looking at activity 2 here. We're going to talk about conjugate acid-base pairs. Finally, we're into chapter 4, which is all about acid-base chemistry. So, acid-base chemistry. We have to know that acids have a proton to donate. This is called a Bronsted definition. So when I say that, don't take it lightly. Proton that you learned in 141 means this particle, which is equivalent to this particle. All that a hydrogen ion has is a proton. Okay? There's nothing else there. So why don't we call a hydrogen ion a proton until the end of time? Because, yeah, I'm going to be doing that. So when I say proton and you don't know it's H+, you're not going to understand acid-base chemistry. So what I want you to do is remove a proton from these acids. These are acids. And they're going to lose a proton to give the thing you draw. Let's see who's paying attention. If I remove a proton from this species, how many hydrogens are left? Answer, 5. What's the charge? It's just as important as the formula. Don't tell me when you lose a proton from a neutral molecule that you're still neutral. The math doesn't work. If you're losing a proton, you better end up being an anion. So you take away a proton from this, and you get this. Oh, sorry. Not a plus. You can't have 2 pluses. It's a minus. I took away a proton. There you go. Why is it a minus? You want to know really why? Well, there's a lone pair on this carbon that wasn't here before. Yeah, I know you don't usually do that. That's a very unhappy carbon. But the only way for it to be an anion is to have a lone pair. So there's your answer. Now take away a proton from a species that already has a plus charge and you're ending neutral. I hope that makes sense. If you add this to this, you get this, okay? Look, this to this gives this. Whatever I draw here with this should give this. So CH3 twice. NH. Oh yeah, that's an amine. Yeah, amines are bases. This is the base. This is its conjugate acid. These are called conjugate acid-base pairs that we're drawing. Now, a very important thing I'm going to bring up right now. This species has an ion that doesn't ever do anything. Ions from the first column of the periodic table that aren't hydrogen, we're talking lithium, cation, sodium, cation, potassium, cation, rubidium, cation, cesium, cation. We'll never talk about francium, but if we did, it would be a cation that we're talking about. These are called spectators. They never do anything. Please don't pretend they're important. In fact, acknowledge they're not important by doing this every time you see them. K plus has just been crossed off. That means what's remaining is an anion. please put the anion where it belongs. Don't tell me it's with the hydrogen. It's with the oxygen. All of your polyatomic ions that have oxygen, that's where the minus lives. Okay, now I need to take a proton away from that thing. So it's a minus already, and you're removing yet another plus. So it's going to be a -2. And you're going to have only one H left. H, PO4, 2 minus. Just to be clear, I'm separating my answers with this yellow line. And there you have the answers. Okay, so let's move our comment here over to here. If I need to draw the conjugate acid of the species below, that means these are the bases. Before, we had an acid and we had to come up with the base. Now we're starting with the base and giving it a proton to make the conjugate acid. Where are you going to put a proton on this without creating an octet violation? All the carbons have full octets, no more room for a bond. O has lone pairs, 2 of them. You can use one of them to make a bond. So CH3, CH2, O, CH3, and I want you to put the H where it belongs, on the O. Yes, that is the conjugate acid of that species. And of course, you're doing this. This minus goes with the O, minus goes with the O. And that's a hint where the H goes. H plus. H plus is attracted to O minus. That's where you're putting it. All right, so we're going to put an H in front. And the rest of the species. That's a carboxylic acid. Makes sense. We're asked for the acids. And H2PO4 negative. When you give it a proton, the minus will disappear. And this one is phosphoric acid, isn't it? So I just really need the 6 answers, okay? This is a short one. This should not take long. Can you copy this answer, this answer, this answer, this answer, this answer, this answer? Everything surrounded by yellow. You don't need anything else. Just separating my answers out here, 6 of them. And you copy those, take a screenshot right now. And we'll make it due at 11:55, but I'll give you till noon. I will give you till noon. So I will see you again at noon.
Wait, Professor.
But we have a question.
The last submission for activity 1 is still due at 11:30. It never changed. So I don't think anyone was able to submit it.
Nobody was able to submit it. I'm going to reopen submission area 1, 2. I thought I took care of that. I apologize. So this one's going to be, I'm going to make them both noon. Can you make sure you submit the right one to the right area?
Okay.
I will make them both noon right now. All right, here we go.
Hello, Professor. Can you hear me?
Yeah. Yes.
For A, isn't CH3, CH2, OCH3 already negative?
We're going back to sharing screen. He's asking for A in the second one. I guess I should have labeled that a little better. Are we sharing the screen yet? No, starboard. We are doing I trying there. And he says that when you add H plus, you should get an anion.
No, shouldn't it be 0? Or because like the O can only
the charge cannot be the same beginning to end. It has to be different by +1.
Isn't it at the beginning? Isn't it -1? Because
it's 0 at the beginning. There's no formal charges whatsoever on this species.
Doesn't that mean that you have 5 bonds on the middle carbon?
I
If-
don't have any carbons with 5 bonds, no.
Because
Octet, octet, octet. The O still has an octet. You want to see the full octet on the O?
Oh wait. Oh wait. Wait.
Here it is. Here's the O with its full octet. There's the bonds on the O. It's got a full octet. You've heard of O plus before, I'm pretty sure. Hydronium. If not, you're going to review hydronium as you're studying chapter 4. It's very common. Okay? I'll be
Okay.
making the deadline noon for activities 1 and 2, and I apologize about activity 1. I must have not hit save. Anyway,